Betelgeuse or Bug Jew. A red beast star almost there, a cosmic miracle, expecting that you put it where the sun is. It would contact the circle of Jupiter. It's colossal, completely fickle, and it will explode. Plan for an immense disaster of never-before-seen scale. Betelgeuse, the red Goliath star on the edge of our inestimable framework, is passing frightening messages through space. Cosmologists have found something significantly upsetting about this tremendous object using the James Webb Space Telescope. Renowned scientist Brian Cox has issued a serious caution. The inquiry that keeps on arising is, are we going to witness an inestimable blast, an impact that will change the night sky forever? The puzzle of Betelgeuse. In the boundlessness of the universe, stars live and die in dumbfounding ways. One star has caught the eye and concern of both space specialists and the public. Betelgeuse, a red supergiant star in the constellation Orion. It is incredibly colossal and ancient. Its exceptional reddish hue and fluctuating brightness have long been captivating. Recent events have heightened interest in this massive star, as we uncover more about Betelgeuse and move closer to a potentially extraordinary event in its history. But what might these changes in Betelgeuse mean? Are we witnessing the prelude to a grand cosmic event on a vast scale? Betelgeuse's colossal size and life cycle. Betelgeuse is a magnificent giant, over 700 times larger than our Sun. Its size is almost beyond human comprehension. Imagine a star so immense that if it replaced our Sun, its surface would extend beyond Mars' orbit, enveloping Mercury, Venus, Earth, and Mars. This colossal size reflects its stage in the stellar life cycle. As a red supergiant, Betelgeuse is nearing the end of its life, expanding and cooling after exhausting the hydrogen at its core and fusing helium. Betelgeuse is estimated to be 8 to 8.5 million years old. While young in human terms, it is ancient in cosmic terms. Over millions of years, Betelgeuse has undergone profound changes, evolving from a hot blue star to the red giant we observe today. Betelgeuse's unique characteristics. Its red color arises from its cooler surface temperature compared to stars like the Sun. While the Sun's surface is around 5,500 K, Betelgeuse's is about 3,500 K. This cooler temperature allows it to emit light at wavelengths that make it appear red. Interestingly, historical records from Roman and Chinese times indicate that Betelgeuse was yellow as recently as 2,000 years ago. By the 9th century, Arabic astronomers noted its red color. This shift signifies the star's development over centuries. Recent observations and mysteries. In late 2019, Betelgeuse began to dim dramatically, a phenomenon now known as the Great Dimming. By February 2020, it had reached its faintest brightness, alarming astronomers. The dramatic change led to various hypotheses, including the possibility of an impending supernova or dust obscuring the star. Concluding thoughts. Betelgeuse remains a subject of fascination and intense study. Whether it will soon end in a brilliant supernova or continue its life as a red giant, its story offers profound insights into the life cycle of stars and the dynamics of the cosmos. Insights from the James Webb Space Telescope and Hubble observations. The James Webb Space Telescope, alongside Hubble, has provided invaluable insights into Betelgeuse's recent activity. Observations suggest that the dimming was likely caused by an enormous amount of hot material ejected from the star's surface. This material cooled as it moved away, forming a thick dust cloud that temporarily obscured a significant portion of the star's light. This event was unprecedented in its scale and rapidity, challenging previous understandings of mass loss in red supergiants. Hubble's ultraviolet spectroscopic measurements detected dense, heated material moving through Betelgeuse's atmosphere at speeds of approximately 200,000 miles per hour. This confirmed that a substantial portion of the star's southern hemisphere experienced a massive eruption, ejecting more material than expected for a star of its type. What does this mean for Betelgeuse's future? While the Great Dimming raised concerns about an imminent supernova, most scientists believe that Betelgeuse is not quite at the end of its life. Its behavior is consistent with the late stages of a red supergiant's evolution, which can last for thousands or even tens of thousands of years. However, the unusual mass ejection event has highlighted how little is known about the dynamics of massive stars. If Betelgeuse does go supernova, it would be an extraordinary event visible even during daylight hours and would provide astronomers with an unprecedented opportunity to study a supernova up close. The impact of a Betelgeuse supernova. At approximately 725 light-years from Earth, Betelgeuse is far enough away that its supernova would not pose a threat to our planet. However, the event would be spectacular, outshining the full moon in brightness and casting shadows at night. The supernova would also enrich the surrounding interstellar medium with heavy elements, contributing to the formation of new stars and planetary systems. This process, known as nucleosynthesis, is essential for the cosmic recycling that creates the building blocks of life. Lessons from Betelgeuse. Betelgeuse serves as a natural laboratory for studying the life cycle of massive stars. Its dramatic changes remind us of the dynamic and ever-evolving nature of the cosmos. Events like the Great Dimming challenge existing models and inspire new questions about the physics of stars. The ongoing observations by telescopes like Hubble and James Webb ensure that Betelgeuse remains a focus of scientific curiosity. Whether it explodes tomorrow or thousands of years from now, its story continues to captivate astronomers and the public alike. A final thought. Betelgeuse, with its colossal size, fiery temperament, and unpredictable behavior, stands as a testament to the universe's power and mystery. It is a vivid reminder of how much remains to be discovered about the stars that shape our cosmos, the broader implications of Betelgeuse's behavior. The recent changes in Betelgeuse are not just about one star. They have implications for our understanding of stellar evolution and the universe's dynamic processes. Observing Betelgeuse's activity provides astronomers with a unique opportunity to refine theories about massive stars' life cycles and death throes. Massive stars like Betelgeuse play a critical role in the cosmos. When they end their lives in supernova explosions, they distribute heavy elements, like iron, gold, and uranium, into the surrounding space. These elements are essential for forming planets and even life itself. Other historical supernova events. If Betelgeuse does go supernova in our lifetimes, it will join the ranks of historically significant stellar explosions. Notable examples include 1. SN 1054. Observed by Chinese and Middle Eastern astronomers, this supernova left behind the Crab Nebula, one of the most studied remnants in the universe. 2. SN 1604. Kepler supernova, documented by Johannes Kepler. This was the last supernova visible to the naked eye in our galaxy. 3. SN 1987A. Located in the Large Magellanic Cloud, this supernova provided invaluable insights into the physics of stellar explosions and neutrino emissions. Each of these events significantly advanced our understanding of the cosmos. Betelgeuse's potential explosion would be similarly transformative, providing an unprecedented look at a supernova in real time. The role of modern technology in decoding Betelgeuse. The advancements in telescope technology have been pivotal in studying Betelgeuse. Instruments like the James Webb Space Telescope and Hubble allow astronomers to observe phenomena in wavelengths that were previously inaccessible. For instance, the ability to analyze ultraviolet and infrared light provides critical data about the star's atmosphere, mass loss, and surrounding dust clouds. Combined with ground-based observatories, these tools form a comprehensive monitoring network, ensuring no detail about Betelgeuse is missed. Betelgeuse as a window into cosmic mysteries. Betelgeuse is more than just a star. It is a window into the universe's fundamental processes. Its unpredictable nature challenges astronomers to refine their models and explore new questions. How do massive stars lose mass in their final stages? What triggers the transition from a red supergiant to a supernova? How does this process affect the surrounding interstellar medium? Answering these questions will deepen our understanding of the life and death of stars, offering insights into the origins of galaxies, planetary systems, and even life itself. The human connection to Betelgeuse. Betelgeuse has been a source of wonder for centuries, inspiring myths, stories, and scientific inquiry. Its position in the Orion constellation makes it one of the most recognizable stars in the night sky, a beacon of both beauty and mystery. As we continue to study Betelgeuse, we are reminded of humanity's enduring curiosity about the cosmos. Its potential supernova would not only be a spectacular event, but also a unifying moment, capturing the imagination of people around the world and reinforcing our connection to the universe. What happens when Betelgeuse goes supernova? When Betelgeuse eventually goes supernova, the event will be nothing short of extraordinary. Here's what scientists expect will occur. 1. The initial explosion. Betelgeuse's core will collapse once it can no longer sustain nuclear fusion. This collapse will trigger a massive release of energy, producing a supernova explosion. The star will release as much energy in a few seconds as the sun emits over its entire lifetime. 2. Brightness increase. The explosion will make Betelgeuse one of the brightest objects in the night sky, rivaling or even surpassing the full moon. It will likely remain visible during the day for weeks or months. 3. Shock waves and ejecta. The explosion will eject massive amounts of stellar material into space at high speeds. This material will form a nebula around the star's remains, creating a spectacular sight visible to telescopes for centuries. 4. Neutron star or black hole. After the explosion, Betelgeuse's core will either collapse into a neutron star or a black hole, depending on its mass. A neutron star is an incredibly dense remnant, while a black hole is a region of space where gravity is so strong that not even light can escape.